Good morning and Jai Hind to all. Last video we discussed what is on and on to types of function, on and on to function, and we do some problems based on that topic. That's our simple questions. Now discuss some set builder form of some function and how to find on and on to of that type function. Okay, let us start the class. A function f from n to n defined by a function f from n to n defined by a function f from n to n defined by f of x is equal to x square. Here f of x is equal to x square. Here we check given function is 1 on or on to. Check given function is 1 on or on to. First of all, we form an arrow diagram. First of all, we form an arrow diagram n to n. Our function is defined from n to n. Okay. The elements of natural number you already know: 1, 2, 3, 4, 5, 6, 7, etc. Here also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Okay. So what is the image of 1? Our function is f of x is equal to x square. Then what is f of 1? F of 1 is 1 square, that is 1. Now the image of 2, 2 square, that is 4. Now the image of 3 is 3 square, is 9. Now the image of 4 is 16, etc., etc., etc. 5 image is 25, 6 image is 36, etc. That means here different elements of the first set has different image in the second set. Different elements of the first set has different image in second set. Now how to prove this case? Okay, that is our function is f of x is equal to x square. First of all, we prove that function is 1, 1. Clearly we know function has different elements has different image. If you suppose a function is function is 1, 1, then we prove generally generally we have to prove that our function is 1, 1. How to prove generally? It is, you know the condition, as x1 is equal to x2 implies f of x1 equal to f of x. That's the definition. Or x1 not equal to x2 implies f of x1 not equal to f of x2. Here we take f of x1 is equal to f of x2 implies what is f of x1? x1 square equal to x2 square. That implies taking root on both sides, there is x1 is equal to x2 and therefore f is 1, 1. So function 1 ആണെങ്കിൽ general ആയിട്ട് വേണം നിങ്ങൾ പ്രൂവ് ചെയ്ത് കൊടുക്കുക. ഈ ഒരു കണ്ടീഷനിലൂടെ പ്രൂവ് ചെയ്യുക. f of x1 equal to f of x2 implies prove that x1 is equal to x2. Suppose the function is not on or not on, we use a simple example. Contradict ചെയ്യുന്ന ഒരു എക്സാമ്പിൾ മാത്രം അവിടെ സ്റ്റേറ്റ് ചെയ്ത് കൊടുത്താൽ മതി. Clearly function is not on or not on to clear ആവും. Okay. Here our function is not on to because on to definition പറയുന്നത് every element of the set second set has at least one pre-image in the first set. Every element of the second set has at least one pre-image in the second set. Here the element 2 has no pre-image, 3 has no pre-image, 5 has no pre-image, and 6, 7, etc. has no pre-image. You take any example, any values. Okay, let 2 is an element of n. Let 2 is an element of n. Here there is 2n. First is a domain and second is codomain. Well, let 2 element of n in the codomain of f. The codomain of f. The 2 element of n in the codomain of f. There exists no pre-image. There exists no pre-image. There exists no pre-image in the domain. And here what is domain? The domain n of f. Therefore, f is not onto. Therefore, f is not onto. That's all. Here our function is 1 on, but our function is not onto. Because the element 2 has no pre-image, 3 has no pre-image, 5 has no pre-image, different a lot of numbers has no pre-image, and therefore function is not. ഇപ്പോൾ ഏതെങ്കിലും ഒരു എക്സാമ്പിൾ ഒരൊറ്റ കോൺട്രഡിക്ഷൻ കാണിച്ചു ഏതെങ്കിലും ഒരു എലമെൻറ്റ് എടുത്തിട്ട് ഈ എലമെൻറ്റ് പ്രീഇമേജ് ഇല്ലാത്തതുകൊണ്ട് ഫംഗ്ഷൻ ഈസ് നോട്ട് ഓൺ ടു എന്ന് സ്റ്റേറ്റ് ചെയ്യാം. ഓക്കെ, നൗ do one more problem based on this function. A function f from z to z defined by a function of from z to z defined by a function of from z to z defined by f of x is equal to same function x square. Check if is 1 on or on 2. Check if is 1 on or on 2. Here also we form, first of all we form an arrow diagram. Is z is also z, etc. We form minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, etc. Here minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Okay. Now the image of minus 3, you know the image of minus 3 square is answer is 9. Clear? Minus 2 image is 4, minus 2 image is 4. Now minus 1 image is plus 1, minus 1 image is plus 1, and 0 square is again 0. Again 1 square is 1, 2 square is 4, and 3 square is again 9, etc., etc., etc. 4 square is 16, etc. Okay. Here clearly you know here function is clearly is not 1 1, because the element minus 1 has the image is 1, also 1 is also has the image is 1. There is different elements have different image, then the function is to be 1 1. Here there are different elements but the images are same. That means our which contradict the definition of 1 1 function. That means here you take an example for checking 1 to 1. Clearly f is not 1 unclear. Now we take any example x1 and x2, you take any example, you take x1 equal to minus 1 or minus 2 2, any example, no problem. Let x1 is equal to minus 1 and x2 is equal to take x2 is equal to plus 1, and therefore f of x1 is equal to minus 1 square, we get answer 1, and f of x2 is 1 square is also we get answer 1. Here x1 and x2 are not equal, here x1 is not equal to x2, that implies we get answer f of x1 is equal to f of x2. That means our definition contradicts the condition, that is x1 is not equal to x2 implies f of x1 not equal to, equal to f of x2. As x1 is not equal to x2 implies we get f of x1 not equal to f of, then the function is said to be 1 1 here, but x1 and x2 are different elements, their images are same, and therefore our function is not 1 1. Our function is not 1 1. Okay. Now check function is onto or not. Clearly a function is not onto, because we get only square values. The set of all integers contain negative integers also. Negative integers has no pre-images, and therefore minus 1, minus 2, minus 3, etc. has no pre-images, and therefore function is already not onto. And the second case, let let minus 2 is an element of z in the domain of the codomain of f. The codomain of f. There exists no pre-image. There exists no pre-image in the domain. The domain z of f, and therefore f is to be not onto. Okay. Here the function is not 1 1 and not onto. Similarly, we prove this function defined for a function of from R to R defined by f of x equal to x square also same. We get the same answer. That function is also not 1 1 and not onto. Okay. Now discuss another type of question. A function f from R to R defined by f of x is equal to mod x. It is a modulus function. This function is already learned in your first year classes. Different form of function, and that here now we check given function is 1 on or onto. A function f from R to R defined by f of x equal to mod x. Check if is 1 on or onto. First of all, we form these two sets, that is set of all real numbers. Okay, collection of real numbers is represented using arrow diagram. R to R is very difficult to plot all the real numbers in arrow diagram. So we consider some integers, that is enough, etc. Minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, etc. Here also minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, etc. There are a lot of numbers lying between 0 and 1. Plotting these numbers is very difficult because space is not available. So we plot only integers. That's enough to prove 1 on or onto. Okay, here the image of minus 3, you know, the modulus value means we get an absolute value, that is a positive value. For any negative or a positive value, we get modulus value become positive. That is minus 3 images, modulus of minus 3 is we get a plus 3. Then modulus of minus 2 is again we get a plus 2. Minus 1 modulus value is plus 1. 0 image is also 0. You know, modulus value 1 is again 1. 2 images again 2, 3 images 3, 4 images 4, etc., etc. Okay, that is, here the element minus 1 image is 1, 1 image is also 1. That means here x1 and x2 are two different elements, but their images x1 and x2 are two different elements, their images are same. That means which contradict our definition of one-on function. That is, okay, now check 1 1. Let you take x1 is equal to plus 1 and x2 is equal to take a minus 1. Here you know f of x1 means modulus value of plus 1 is 1. F of x2 is modulus value minus 1 is again we get answer same one. That is, here x1 is not equal to x2. That implies we get answer f of x1 is equal to f of x2. Here x1 is not equal to x2 implies we get answer f of x1 equal to f of x2. That means our function is not 1 1. Our function is not 1 1. Here we have to prove that our function, a function of from R to R defined by f of x equal to mod x is check f is 1 1 or 1 2 or here first of all we get answer f is not 1 1. Now check 1 2. Clearly you know we get only positive values. Images are always positive and therefore on the real system negative numbers has no pre-images. Here we consider not only not integers, we consider all real numbers. Suppose we take a 0.5, image of 0.5 is also 0.5, modulus of minus 0.5 is we get answer 0.5, also not 1 1. Okay, here function is not 1 2 because the element negative numbers, that is minus 3, minus 2, minus 1, minus 4, etc. has no pre-images. You take any number and you say that there is no pre-image and therefore function is not on 2. One number in pre-image number. Okay, you take minus 1 or minus 2 is an element of R in the codomain of F. The codomain of F. There exists no pre-image. There exists no pre-image in the domain R of F, and therefore our function is not onto. Our function is not onto. Okay, clearly given function is not 1 1 and not onto. Our function is. Our question is function of from R to R defined by f of x equal to mod x is neither 1 1 nor on 2, or second option a function of from R to R defined by f of x equal to mod x. Check f is injective or surjective, or check f is 1 1 or on 2. In all these cases we get answer f is not 1 1 and f is not on 2. Okay. Now write one more problem. A function f from R to R defined by a function f from R to R defined by f of x is equal to 1 for x greater than 0, 0 for x equal to 0 and minus 1 for x less than 0. A function f from R to R defined by f of x is equal to 1 for x greater than 0, 0 for x is equal to 0 and minus 1 for x less than 0 is neither 1 1 nor on 2. A function f from R to R defined by f of x is equal to 1 for x greater than 0, 0 for x is equal to 0 and minus 1 for x less than 0 is neither 1 1 nor on 2. This type of function is named, another name is Sinum function, SIGNUM, Sinum function. This type of function name is Sinum function. This type of function already learned in our first year classes. Okay, now check the now we have to prove that this function is neither 1 1 nor on 2. First of all, we form an arrow diagram. Real to real, our function set is first set is real and second set is also real. etc. Here we plot minus 3, minus 2, minus 1. All real numbers plotting is very difficult. So we collect some integers, minus 3, minus 1, 0, 1, 0 to 1. There are infinite numbers are there, 0.1, 0.2, 0.3. But plotting is very difficult. So we take only integers. That is enough to prove is 1, 1 or 1, 2, 3, 4, etc. Here also minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, etc. Okay. You know, our Sinum function states that for any positive real number, image will be 1, and for x is equal to 0, image is 0, and for any negative real number, our image is minus 1. For any positive real number, our image is 1. For any negative real number, image is minus 1, and 0 image is 0. Okay, now plot the images. The image value of minus 3, you know, f of minus 3 is less than 0, and therefore the image is minus 1. Minus 3 image is minus 1. Okay, minus 2 image is minus 1. Minus 1 image is minus 1, but 0 image is 0. Again, 1 image is 1. 2 image is 1, 3 image is 1, 4 image is 1, etc. etc. For all positive real numbers, there is 1.5 image is also 1, 2.5 image is also 1. For all positive real numbers, image will be 1. And for all negative real number, image is minus 1, and 0 image is 0. That means our range is minus 1, 0 and 1. Clearly our function is not 1, 1, 1. If you take x1 is equal to minus 1 and x2 is equal to 1, we get different images. Different elements have different image, but that is possible only these two cases. Or minus 2, 2, that is possible. ഒരു ഫംഗ്ഷൻ 1 അല്ല അല്ലെങ്കിൽ 1, 2 അല്ല എന്ന് കോൺട്രഡിക്ഷൻ ചെയ്യാൻ ഒരു എക്സാമ്പിൾ മതി. ഒരു എക്സാമ്പിൾ ഒരു മിസ്റ്റേക്ക് ആ ഒരു ഫംഗ്ഷൻ്റെ ഡെഫിനിഷൻ തെറ്റിക്കുന്നത് കാണിക്കാൻ ഒരു എക്സാമ്പിൾ മതി. Suppose x1 is contradict here. For 1, 1, we take x1 is equal to 1 and x2 is equal to 2. x1 and x2 are two different elements, but their images same. അപ്പോൾ അവിടെ നമ്മൾ ആ ഒരു ഡെഫിനിഷൻ കോൺട്രഡിക്റ്റ് ചെയ്തു. ഈ കേസ് എടുക്കുമ്പോൾ x1 മൈനസ് 1 x2 ഈക്വൽ ടു 1 എടുത്തു കഴിഞ്ഞാൽ ഇമേജസും ഡിഫറൻ്റ് ആയിട്ട് കിട്ടും. പക്ഷേ അത് നമ്മൾ ജനറലായിട്ട് നമുക്ക് എഴുതാൻ കഴിയില്ല ഫംഗ്ഷൻ ഒന്നാണെന്ന്. കാരണം x1 1 x2 2 എടുക്കുമ്പോൾ ഇമേജ് സെയിം കിട്ടുന്നുണ്ട്. അപ്പോൾ അവിടെ നമ്മൾ 1 ഡെഫിനിഷൻ കോൺട്രഡിക്റ്റ് ചെയ്യുന്നുണ്ട്. കോൺട്രഡിക്റ്റ് ചെയ്യാൻ ഒരു എക്സാമ്പിൾ കാണിച്ചു കൊടുത്താൽ ദാറ്റ്സ് എനഫ്. പക്ഷേ എല്ലാ കേസിലും പ്രൂവ് ചെയ്ത് വന്നു കഴിഞ്ഞാൽ ഡിഫറൻ്റ് എലമെൻറ്റ്സ് ഡിഫറൻ്റ് ഇമേജ് കിട്ടിയിരുന്നെങ്കിൽ ഫംഗ്ഷൻ നമുക്ക് ജനറലായിട്ട് പ്രൂവ് ചെയ്യാൻ പറ്റും. ജനറലായിട്ട് f of x1 ഈക്വൽ f of x2 ഇംപ്ലൈസ് ഫംഗ്ഷൻ ഈസ് 1 എന്ന് എഴുതാൻ പറ്റും. പക്ഷേ ഇവിടെ കോൺട്രഡിക്ഷൻ നടക്കുന്നുണ്ട്. കോൺട്രഡിക്റ്റ് ചെയ്യുന്ന ഏതെങ്കിലും രണ്ട് എലമെൻറ്റ് കൺസിഡർ ചെയ്യുക. You take x1 equal to 1 and x2 is equal to 2, and therefore our images f of x1 is 1, f of x2 is also 1, because 1 and 2 have same images, and that means x1 is not equal to x2 implies we get answer f of x1 is equal to f of x2, and therefore our function is said to be not 1, 1. Our function is said to be not 1, 1. Now check surjective, that means 1, 2. You know, only 3 images are possible here, minus 1, 0 and 1. All other has no pre-images. Okay, let 1, 2, 4, 1, 2. Let suppose you take a 2. 2 is an element of R in the codomain of, you take any number, minus 1, 0, 1 avoid it, any number you consider. 2 element of R in the codomain of F, 2 element of R in the codomain of F, there exists no pre-image. There exists no pre-image in the domain R of F, and therefore F is not onto. F is not onto. Clearly, given function is not 1, 1, and F is not onto. Okay. Okay, that's all. Now the next video we will discuss more problems based on 1, 1 and 1, 2 cases. That mean polynomial function and rational function will be discussed on next video. That's all. Thank you.